everyone. Today we'll be going over the ambiguous case of sine law. So first, let's review the rules of the ambiguous case of sine law. So first, we actually have to use sine law, which is sine A over A is equal to sine B divided by B. So this is the angle over the length, basically. So what you have to do is you have to solve for sine B first, and then once you set it equal to sine B, you have to find B using sine inverse. Then once you get that angle, you have to check the second possible angle by doing 180 minus the angle that you get. And lastly, you have to determine if the second angle forms a valid triangle. Now let's go over the first case of the ambiguous case of sine law. So the first case is when there's no triangles. So we'll use this as an example. We have 30 degrees as the angle, A is equal to 4 and B is equal to 10. So let's set up the equation. Sine of 30 over 4 is equal to sine of B over 10. And we'll just rearrange that. So sine of B is equal to sine of 30 times 10 divided by 4. So then we'll calculate B by making it B is equal to the sine inverse of sine of 30 times 10 divided by 4. And that gives us that gives us that this should give you an error on your calculator, which shows us that it's not possible. Or another way you can do it is you just go straight from here, sine B, and you just solve for that, and you just solve for this. So when you do that, you get sine B is equal to 1.25. And that's, you can't inverse this because sine B cannot be bigger than 1. So therefore, there are no triangles. Okay, so moving on to the second case, we have one triangle. So here we have the angle of 30 degrees given, the length of A being 12 and the length of B being 10. So first we set up the sine law. Sine of 30 divided by 12 is equal to sine of B divided by 10. So then you solve for this. You do sine of 30 times 10 is equal to 12. Let me just write that better. Then we can conclude that sine of B is equal to sine of 30 times 10 divided by 12. Then you get sine of B is equal to 0.4167, and B is equal to the sine inverse 0.4167, and and that makes B equal to 24.6 degrees. So this is approximately 24.6 degrees. So now you'd have to check if this has a second angle by doing the second angle. So B2 is equal to 180 degrees minus 24.6. and here we get B2 as 155.4 degrees. Now we can check if this is a valid angle by doing 30, because 30 was the original angle, so we have to use 30. 30 plus 155.4 is equal to 185.4. And 185.4 is bigger than 180. So that means this is not a valid angle. So this is not a valid angle. So that leaves us with the only angle being 24.6. So therefore, there is only one triangle. And now moving on to the last case, we have two triangles. So in this case, we're given 30 degrees as the angle, with length of A is 8 and length of B is 10. So first let's set up the sine law. So sine of 30 divided by 8 is equal to sine of B divided by 10. Then you set it equal to sine B, so you do sine 30 times 10 is equal to sine B times 8. Sine B is equal to sine 30 times 10 divided by 8. So that leaves us with sine B equal to 0.625 and B is equal to sine inverse of 0.625 and B is equal to approximately 38.38. Oh, let me just write this better. 38.7 degrees. So now we have to check for the second angle by doing 180 minus 38.7 degrees. And we get B2 to be 141.3 degrees. Now we have to double check if this is even valid. So we do 30 degrees plus 141.3 degrees, and that gives us 171.3 degrees. And 171.3 is smaller than 180, so it is valid. So then we can conclude that there are two triangles possible. Okay, thank you guys for watching this video, and that's how you solve the ambiguous case of sine law.